the double slit experiment. It's one of the most famous and puzzling experiments in physics. The experiment was first designed in 1801 by Thomas Young and demonstrated wave interference. So what's interference? Well, if you send a water wave through two gaps or slits, then it breaks up into two waves, and these waves interfere with each other. Well, where the peaks of waves meet, you get constructive interference and it results in a larger wave. But where a peak of a wave meets the trough of a wave, there we have what we call deconstructive interference, where they kind of cancel out and make a much smaller wave. The same happens with light. If you shine it through a double slit onto a screen, then on the screen you see areas of dark and light. The light is constructive interference, which is bright, and the dark is deconstructive interference, which is dim. And this shows that light is a wave, and it works with sound too, with areas of loud and quiet sounds. But in 1923, they started experimenting with quantum particles like electrons through a double slit. So imagine you were firing solid objects through this, like little bullets. Then you'd expect that the screen behind it would have two areas where the bullets are hitting, and maybe some others scattered about from ricochets. But what actually happened is that they saw a perfect interference pattern, which is weird because it meant that these little particles were interacting with each other just the same way as a wave would. So maybe there was some kind of mysterious force that we didn't know about yet that was causing this. So they decided to investigate further and send an electron through one at a time so they couldn't possibly interfere with each other. Surely now it would make two nice bands. And it was totally random and unpredictable where these electrons started hitting on the screen. But fast forward the experiment, and the interference pattern emerged once again. This was so strange, and the only conclusion they could really draw was that the particle was somehow going through both slits, acting like a kind of wave and interfering with itself, and then being detected again as a particle somewhere on the detector screen. So they then decided to work out which slit this particle is actually going through. So they placed a detector at one of the slits. The device could sense the passage of an electron without actually capturing it. So if it didn't detect it, but then it appeared on the screen, then they would know it had gone through the other slit. So it kind of forces the electron to make a choice which slit it's going to go through. But with the detector on, all of a sudden the electrons start behaving like conventional solid particles and forming two bands on the screen. But turn the detector off and the interference pattern re-emerges. It's a bit like the particles didn't want to give away what they're up to. A century on, and we still don't have an accepted interpretation for this experiment. But some of the conclusions drawn were, the mere act of observing and measuring a particle seems to stop it acting like a wave and more like a conventional solid particle. At its most fundamental level, reality is random but probabilistic. We can't know where a particle will hit on the detector, but we can give a probability for where it's most likely going to end up. And finally, we can't know a particle's location. It might not even have one until it's detected. And that is